Woodworth here, and we're working on lesson 8.2, solving two-step equations. Exciting. You know what I always say? It's a beautiful day for math, even though it's a Monday. Let's get after it. Here we go. So we're going to solve these types of equations here. They have two operations. See, there's addition, obviously, there, and there is multiplication there between the -3 and the x. All right, and we're going to try to figure out which one to undo first to isolate that variable. Now, my favorite thing to say as a math teacher, you're going to hear me say it a lot, let's use inverse operations to isolate the variable. It just has a nice ring to it. It really rolls off the tongue in such a satisfying way. All right, now you should already have this stuff copied, but if you don't, pause and get it down now, okay? When we solve, we're always going to look to simplify. You don't always have to simplify because there might not be something to simplify in the problem, but just look. It's just going to take you 2 seconds to look, see if you can simplify. Then if everything's simplified, then we're going to solve. So this is following order of operations. This is following the reverse of order of operations, undoing all the operations in reverse order. So this is regular PEMDAS, and I like to call this SAD MEP, the opposite of PEMDAS. Got me? Okay. You can see it visually down here. See SAD MEP or PEMDAS. Got it? All right. So simplifying, typically in these types of problems, we're going to simplify the left and right side of the equation by using distributive property and combining like terms. All right. And as you can see, it says if necessary, meaning often you won't have to simplify. You can just skip to the second step, which is using reverse order of operations to solve, right? And what is solving? In algebra, it's using inverse operations to isolate the variable. All right, and solving is also looking for a solution. What's a solution? A solution is a value for the variable that makes the equation true. If I had to pick something, that'd be my second favorite thing to say in math. All right, I'll have to write that down. Anyway, we are going to use reverse order of operations. So your first step is going to be use addition and subtraction, and specifically the addition and subtraction property of equality. That means what you do to one side, you have to do to the other. Okay, use that property to cancel out the constant term. Constant term, what is that again? That's the term without the variable. Remember, a new term starts every time you see an addition or subtraction symbol. Okay, now after you cancel out the constant term, if there is one, using addition and subtraction, we're going to use multiplication or division property of equality to cancel out the variable's coefficient. All right, remember what the coefficient is? Often it's right to the left of the variable, but more accurately, it's what's multiplied by the variable. Okay, so if you have 2x, it's the 2. If we zoom up here, it's this -3. Here's my constant, no variable in that term. Here's my coefficient because it's part of this variable term. All right, it's just the -3. All right, and then we won't be dealing with anything that involves these guys right now. Okay, hopefully you get rid of any parentheses because in that first simplifying step, we use distributive property to kind of get rid of them. Okay, so that's the intro. We're going to be referring back to this page to make sure we're following all the steps. Now it's time for our practice. Let's go. Okay, some examples here. So our first step is to look at the left side of the equation and see if there's anything to simplify. There's no distributive property. That's what we look for first. And then look to see if you can simplify by combining like terms. Well, we have two constant terms, a +7 and a +2. That can be simplified. Okay, so we keep the 3a and we combine those to make it more simple. It's easier to say +9 than it is to say +7 +2. All right, and then we're going to bring down our 33. Now there's nothing to simplify over there, so we're good to go. Okay, we always check the left and the right side of the equation to see if you can simplify it. Now we're ready to solve. So our first step was to simplify. And we just combine the like terms there. Okay, next, now we're going to solve. We're going to try to what we call isolate the variable. we're going to get that a all by itself so we can know what it equals. What is the solution? What will make this equation true? Okay, so let's do that. And our first step in solving is to get rid of a constant term if we can, and we do that by addition or subtraction. So we're going to, what would cancel out plus 9? Okay, we would cancel that out by putting minus 9. Now, I'm going to draw this line down. I'm going to use this line to line up my equal sign. Sorry, there's going to be one here actually. Okay, because I'm going to write what we call equivalent equations. If I do a legal mathematics move, right, what I do to one side, I do to the other, then I'm always going to get a new equation that has the same solution as the original equation. And that's the whole theory behind this, okay? That's the whole reason we can do this. If we do this legally, this legal maneuver, the subtraction property of equality, then we're going to get an equivalent equation which will have the same solution as the original, and we do it so that we can eventually get down to an equation that tells us what the a is equal to. All right, so plus 9 minus 9 cancels out. We're going to bring down what's left over, the 3a. Okay, what did we use there? We used the subtraction property of equality to isolate that variable there. Now we're going to do 33 minus 9, which comes to 24. Now our next step, okay, remember for reverse order of operations, right? We got rid of the constant term by using addition and subtraction. We use subtraction in this case. And then we're going to divide or multiply to get rid of the coefficient of the variable. All right, so you see that we have this coefficient here. It's multiplied by the a. So what are we going to do? We're going to do the inverse operation. To undo multiply by a, we're going to divide by, multiply by 3. We're going to divide by 3. Okay, 3 divided by 3 equals 1. So we get 1a. We don't have to put the 1 identity property. Okay, 1a. And then we have 24 divided by 3, which gives us 8. Almost said 6. Anyway, so then we used the, division property of equality. All right, so quick review. We simplified first. Then we started canceling out everything. We wanted to cancel everything out so we could isolate this variable. And if we follow the rule where you do it, what you do to one side, you do to the other, then you'll get an equivalent equation. So to undo add 9, we subtracted 9, have to do it to the other side. To undo the multiply by 3, we divide by 3, we have to do it to the other side. And we come down here and have a solution. Now we can check that quickly in our heads. Let's go back to the original. What if I did 3 times 8? What would I get? 24. Then add 7 to 24, 31. Then add the 2 to 31, 33. So this whole left side would equal the right side of 33. Okay, so you can quickly check your answer. Let's go to the next example. All right, there's nothing to simplify over here, nothing to simplify over here, so I'm going to draw my line down so I can keep my equal signs organized. All right, now we look at this, we see two terms. Okay, a term here and a term here. And we're going to use addition or subtraction to cancel out the constant term first. So minus 8, we're going to add 8. Okay, inverse operations to isolate the variable. That cancels that out. We bring down the remaining. And we have a new equation, but it has the same solution as the original. Okay, negative 16 plus 8 is negative 8. And now we have to isolate the variable using inverse operations, my favorite saying. We're going to divide by negative 2, divide by negative 2, cancels. X equals a negative divided by negative is a positive. Okay, check it. Negative 2 times 4 is negative 8. Negative 8 minus 8, okay, or plus negative 8, remember, definition of subtraction. Okay. A negative 8 combined with another negative 8 gives us negative 16. So we are correct. Next, moving on. Okay, I threw a fraction in there. All right, but that's just from lesson 8.1, right? How do we get rid of a fractional coefficient? We multiply by the reciprocal, or you could call it refliprocal to kind of help you remember how to find them. Anyway, we don't have anything to simplify over here or over here, so we can draw our line to organize our equal signs. All right, now we have our variable term and our constant term. We always get rid of that constant term first, all right, by using addition or subtraction. You can actually get rid of any term you want by using addition and subtraction. You can get rid of coefficients by using division or multiplication, all right? So anyway, just a little tip. All right, so we want to get rid of that minus 2. How do you think we're going to do that? We're going to add 2. All right, and to keep that equation balanced and make sure I get an equivalent equation down here, I have to do it to both sides, right? So it cancels. 1/4 x, and that's going to be 7. Now, how do I get rid of that fractional coefficient? I'm going to multiply by the reciprocal. I'm going to multiply by the reciprocal on that side to keep it balanced and get an equivalent equation. All right, now what's a number times its reciprocal always equal? It equals 1. So that all cancels out to 1, so we get 1x, but I don't have to put the 1 because it's just extra writing. I know it's 1x without the 1. All right, 4 over 1 times 7 would give us 28. All right, let's check that answer. Plug it in here. What's 1/4 of 28? 7. Minus 2, 5. It works. It makes the equation true. Hopefully it's sinking in. Now this one could be challenging. It trips a lot of people up at first. Okay, again, nothing to simplify on either side. All right, of the equal sign. So we can draw our line down. We're ready to solve. We always look to simplify first. Now, we have 2 terms here. 2 terms. Does this minus sign go with the 9? Or does this minus sign go with the t? Okay, remember, when you move left to right, as soon as you get to a minus, subtraction, or addition symbol, that starts the new term. So this minus goes with this t. Don't forget that. That sign is telling you about this t. It doesn't tell you anything about the 9. That's a positive 9. So careful in this problem. All right? Let's actually use the subtraction, the definition of subtraction here, and change it to plus, negative, and also the identity property, plus negative 1t. Okay, some of you can get away with kind of just bringing that minus sign down, but I want to do it this way. Now, which of these terms are we going to cancel out first? Okay, which of these ones, right? The constant, the one without the variable. How do I get rid of a positive 9? I could add a negative 9, or I could just say, let's subtract 9. Subtract 9. Okay, I get negative 1t equals, because I just brought that down. And when I combine these, right, I have a negative combined with a negative. Okay, you should do plus a negative if you wanted. All right, but it's going to get more and more negative. So that's going to be negative 33. Nope, just joking. Negative 43. There we go. Now, how do we get rid of this negative 1 here? Well, we're just going to divide by negative 1, divide by negative 1. T equals positive 43. Now, let's check that out. Can we put 43 up here? And for t, 9 minus 43? 9 minus 43 is, yes, it would be negative 34. So that is the correct answer. All right. Hopefully you guys are hanging in there. Make sure while you're watching, if you pause and ask Mr. Woodard the question on Go Guardian, that could really be helpful. So take the opportunity to do that. Now, I wanted to do one more with simplifying. One more that had simplifying right off the bat. All right. If you look at the left side and the right side's all simplified. It's just down to one number. But this side has some terms that we can combine. Okay. It has a minus 9c, and it has a plus 3c. If I subtract 9, then add 3, what's kind of the net result? Okay, the net result would be minus 6c. Okay, we combine those, bring down the 58. Now we're ready to solve. I guess I really shouldn't have put this line there. I like to only put that line there when I'm ready to solve. All right, so we have two terms. Okay, we have a positive 4 and a minus 6c. We usually get rid of the constant term using addition or subtraction. I can do subtraction here to subtract 4 minus 4 gets you 0. That cancels. And I have to bring down, now I didn't do it because I'm not in the habit of it, but it might be helpful for you to do plus negative there. Okay, but if I cancel that out, I just know for myself I'm bringing down a negative 6c, or a minus 6c. All right, if I subtract this, excuse me, I get 54. And now to get rid of a coefficient, I'm going to divide, okay, or multiply, but in this case, because it's multiplying, this negative 6c is multiplied by, the negative 6 is multiplied by the c, I can divide by negative 6 to undo it, to reverse it, to cancel it out. Okay, that equals 1, so I have 1c. 54 divided by negative 6 is going to be negative 9. If I go back and check in the original, it's going to be a little tricky. Well, I think we can do it. Okay, 9 times negative 9. I'll do it up here for 9 times negative 9 plus 3 times negative 9. That gets me 4 minus negative 81, which is plus a positive, and then plus negative 27. So this gives me, that gives me 85, and then I have to subtract 85 minus 27, and that would give me 8 and 5, 58. Yes, we got it. Okay. Oops, sorry, I didn't show you my real work there. Okay, I just kind of having trouble doing it in my head, so I just jotted it down real quick to see if I was right. Okay, that was a tricky one and hard to check, so hopefully it didn't get you too upset. Now you have these four to practice, okay, and then I'm going to write the work down and you can check it from there. Good work, guys. Have a terrific, terrific day. And we're back, and there's the answers. Check them, please. Pause, check, and see how you did, okay? Try to find your mistakes. If you can't find your mistakes or are still confused, ask me. Please, ask, all right? We can go through some together, and you'll be just fine, okay? So work hard. Hopefully you did well on these. Pause, and let me know if you have questions. Okay? Hopefully you fixed it all up. Hopefully you're feeling good about it. It's always a beautiful day for math. Woodworth out.